Hello everyone and welcome to this video. Today we are going to be still learning about manipulating and comparing arrays. We're still learning about aggregation, and in this topic we're going to be learning about standard deviation and variance. Now this is where we left off in the previous video. So what I'm going to do, so basically what we're going to learn about standard deviation and variance in manipulating and comparing arrays, and it's still part of aggregation. Okay, so make sure so don't be confused, because in the previous video I gave you a brief demo of standard deviation and variance. I just told you a few of the functions. Today we're gonna go I'm just gonna explain it more to you so you guys understand, because actually it is quite a hard topic to understand. Okay, so without wasting any more time, what we're going to do is we are going to launch our Jupyter notebook. Okay, so what you are going to want to do is you want to search Anaconda. Whoops, what am I doing? You want to search up Anaconda prompt if you are in Windows, or Terminal if you're in Mac. Make sure you know how to set up your environment, because otherwise none of the commands I'm going to type in will work. So please do that. Please watch my video on setting up an environment so you can type in these commands. Okay, so once you've done that, all you need to do is you need to type in conda activate. And you want to activate your environment, which is in users. For me, actually, users, Venka, desktop folders, ML course, practice project, and enter. And this base over here should turn into this path. Okay. Once it's done that, you need to type in Jupyter Notebook, enter, and it will start loading up. Okay, so let's just wait for that to load up. Okay, so this has come up. That means it's loading up now. Okay, so now it has actually loaded up. Let's go ahead and navigate to our project. Okay, so this is where we left off last time. We had a brief intro, so we just did a bit of standard variation, standard deviation, sorry, and variance. And we learned that the standard deviation is the square root of the variance of a number. Okay, so right before here, I am going to put markdown. So as this is still part of aggregation, what I'm going to do is I'm just going to put this within the aggregation topic. Okay, so that is not how you spell standard. Standard deviation and variance. Okay, so one quick thing before we start is I just want to tell you guys a few shortcuts. So if you don't want to keep on saying standard deviation, so what you can do is standard deviation. You can say this as std, and let's take away the colon over here. And you can say variance as var. Okay, so those are some shortcuts. You can say some things. Yeah, so you can say it like that if you would like. Okay, so okay, so let's actually start learning about some more standard deviation and variance. So let's create some two arrays. So first one I'm going to do is I'm going to call this one high var array is equal to np dot array 1 whoops 100 200 300 4,000 5,000. Okay, so we've created a high var array. Then let's create another one called low var array is equal to np dot array. Let's do a nice simple one, 2, 4, 6, 8, 10. Okay, so before we go on, I want you guys to look at these two arrays and just take in what is there and describe each array to yourself. Okay, so if I were to describe it, I would say the values in this high var array, the values are a bit more spaced out. And here they all are equal. They're less spaced out. They're less spaced out. Okay, so it's just 2 every time, and here it's like 99, 100, 100, maybe a few thousand here, and then another 1,000. So let's create this too. Okay, there you go. So this is what I am going to say. So if we run this. Okay, so it's saying NP is not defined. So that is because sometimes your kernel goes a bit weird. So what I'm going to do is I'm going to restart my kernel, and I'm going to run the code all over again. Okay, so I ran it all over again and it managed to work. So what we're going to do is we're going to carry on. So you run this. So let's find the variance of each array. So I'm going to say np.var. I am going to find the variance of our high var array. So you can press tab to autocomplete and it should autocomplete. And then we want to find the variance of our low variance array. So np.var. np.var and just like format this properly. Whoops. There we go. So low var array. If we run this, okay, so what we got is we got this number is like way more bigger than this. So why is this? So basically, if we go up to this, if we look at this variance, it's the measure of the average degree to which each number is different to the mean. Okay, so what is a higher variance? It's a wider range of numbers. Okay, so if we look at our high var array, we've got a wider range of numbers here. And then a low variance is a lower range of numbers. Okay, so if you look here, we've got a lower range because they're a bit less spaced out than this wider range. So this is a wider range of numbers because it's more spaced out and more of a variety. Okay, so this is why we only got 8 for this because it's not that good. These numbers aren't that spaced out from the mean, but these numbers are way more spaced out from the mean. Okay, so hopefully you understood that. So let's find out the standard deviation now. So np.std for standard deviation. We want to find it for the high variance array and the low variance array. So np.std low variance array. Okay, so now we've got this big number and this number is quite small. So let's go and look at standard deviation. So it is a measure of how spread out a group of numbers is from the mean. So let's spell that correctly. How spread out. So it's a measure of how spread out a group of numbers is from the mean. Okay, so if we look at our high var array, if we look at that, we've got loads of spread out numbers. So our high variance array, if we were to calculate the mean, so Basically, let's calculate the mean of both of them so we can find it easier. So np dot mean var array, and we want np dot mean of the low var array. Okay, so the mean of the high variance array is 1600, and any of these numbers would at average be about 2072 from the mean. Okay, so any of these numbers over here would be about 2072 kind of number 2072 away from this mean over here. And whilst we have here, we've got 2 for at an average 2 for our low variance array, because if we call our low var array, then we've got 2, 4, 6, 8, 10, and the mean is 6. So any of these numbers in the low variance array would be at average about 2 from the mean, which is 6. Okay, so we can see this better if we plot it on a graph. So what we're going to do is, if you're in Jupyter Notebook, we can use this magic function, so matplotlib inline, so we can use it. We want to import matplotlib. Okay, I spelled that wrong. Matplotlib dot pyplot, because we're plotting as plt. We want to, so let's see if that gives us no errors. There we go, beautiful. So what we're going to do now is we want to plot, let's plot our high variance array first. So we'll say plt dot hist. We want to plot a histogram of our high var array, and plt dot show, and it should give us a graph. Okay, so let's check the low variance array too, so we can compare them both. So plt dot hist low var array, and then after that it's plt dot show. Okay, so let's compare. Well, let's actually compare with these two. Okay, so what I'm going to do is I'm going to zoom out. Let's zoom out a bit more. Okay, so now we can see them two together. So what do these two show? So what we're going to do is here we can if we look okay, let's just do it down here. If we look at our high variance array. Okay, so these numbers are really spaced out, so that's why there is a lot of white space, because these numbers are actually really spaced out, so there'll be loads of white space. Okay, and most of these numbers are very close to 0, and some of them go to 400, 4,000, and 5,000. Whilst if we look at our low variance array, whilst we look at that, we can see that these numbers are actually equally spaced. So there's some equal spaces and a teeny bit of white space. Okay, and there's 2, 4, 6, 8, 10, and so on and so forth. Okay, so let me just zoom back in again. There we go. That's adequate. So if we zoom back in again, what we're going to, so basically we have learned how to plot things. Okay, so right now I hope you understood this. I hope you understood what this means. So again, if we just write it down again, the variance, okay, sorry, let me just write that properly. Okay, so the variance, what is this? It is the measure of the average degree to which each number is different to the mean. Okay, so what would a high variance be? So a high variance is a more wider range of numbers, so wider range of numbers, so more of a variety. The low variance is a lower range of numbers. Okay, so it's not much of a variety, it's just kind of because if we look at our high variance array, so high var array, it's more spaced out, and if we look at low var array, it is all the numbers are actually kind of equally spaced out. Okay, so also now the standard deviation, so standard deviation is a measure of how spread out a group of numbers is from the mean. Okay, so that is what the standard deviation is. Okay, so again, the standard deviation can also be equal to the square root of the variance. Okay, so I guess that's it for today. Hopefully you learned something new today about standard deviation and you understood it a bit more. If you like this video, please subscribe and leave a comment below. If you have any comments or doubts, obviously comment them down in the comment section. And I guess that's the end of this video. Bye.